So in this video I'm going to go through another way that the intermediate value theorem question will sometimes be asked both on my exams and on the AP exam. And that's in asking you to find the value of c that's guaranteed by the intermediate value theorem. So I'll sort of read through my example here and then I'll ask something of you. So given this function, they want you to find the value of c guaranteed by the intermediate value theorem for f of c equals 3 on the interval between 0 and 10. So the question that I'd like you to try and process is, what is this c that they're talking about? And if you don't remember, go back and look at the notes that you took for the first video on the intermediate value theorem. Go back and remind yourself, what is c? Like I was very clear, I tried to be very clear about it in the first video in talking about what. So go back and look at your notes, see if you can figure out what c is, and then we'll sort of resume the video and talk about it. So the place that the c showed up is that f of c was supposed to be equal to the k value that they wanted us to find, right? And so the idea is, like, we know what this k is. K is basically the desired output. So then that begs the question, what is c? This value of c that they want, what is that thing? Well, from our initial video, we said that c was the input value that leads to that desired output value. So in other words, this question is really just asking, first, show that the intermediate value theorem applies, show that it really would guarantee it, but then find the input value that will give you the output of 3, right? So, I would ask you to now pause the video and go ahead and verify that the intermediate value theorem really does apply to this problem, right? The first thing that we will need to show is we'll need to show continuity, right? So is this function continuous? Is this continuous on the interval? Yeah, just like we've said before, this has no division by 0, and it has no, it's not piecewise, so I'm not worried about that, right? The second thing that we have to consider is we have to look at the endpoints. We have to look at f of 0, and we have to look at f of 10, and we have to figure out if the desired output of 3 is indeed between them, right? So for f of 0, we find that f of 0 is negative 25. We find that f of 10 is 100 minus 30 minus 25. That got a little bit squished over there. It means that f of 10 is 45. Okay, 3 is definitely between negative 25 and positive 45. So because of that, the intermediate value theorem does apply. So just like I did in the previous video, I'll write this out in a complete sentence. The intermediate value theorem will guarantee a value of c with f of c equal to 3 because f is continuous and 3 is between my two output values. So now how do we find c? It's actually a really straightforward thing. We just need to set f of c equal to 3. Now what is f of c? Well, remember what f of x was. F of x, back up in the beginning of the problem, was this guy right here. F of x was x squared minus 3x minus 25. So what would f of c be? Well, f of c would be c squared minus 3c minus 25. We just need to solve this equation. Right, and I'm going to solve that by factoring, not a big deal. So c squared minus 3c minus 28 equals 0. When I factor this, I'll have c minus 7 and c plus 4. So my two solutions seem to be 7 and negative 4. Now the question is, what is the answer to the question? Right? The answer is actually only 7, because my value of c had to be on the open interval from 0 to 10. I was only looking for values that were between 0 and 10. Right? So while c equals negative 4 is a solution, it's not the one that would have been guaranteed by the intermediate value theorem. So when a problem asks you to find the value of c, it means that you're effectively setting your function equal to the output and looking for the input that causes it. The last question I want to address in this video is it ever possible to not find c? Like, is it ever possible that you won't have a guaranteed value of c? And the answer is absolutely yes. It's definitely possible for it to not be possible. When would that happen? If the intermediate value theorem didn't apply. If the function was discontinuous on the interval, or if the output value wasn't in between the two outputs, then you won't be able to find c. And your answer would be the intermediate value theorem does not apply. So just to put that in writing for you, if the function is discontinuous on the interval, or the desired output is not between f of a and f of b, then there will be no guaranteed value of c. By the way, it's okay for the function to be discontinuous not on the interval. It just has to be continuous on the interval in order for the intermediate value theorem to apply. The final thing that I will say is that sometimes these problems are calculator problems. Sometimes you'll need to use your calculator to find the value of c. I think I will be covering that in a later video because I don't want this one to be any longer. So I'll see you there.